How does robotics programming integrate with hardware components? Breaking news in the world of technology. A hot topic right now is how robotics programming connects with hardware components. As industries increasingly adopt automation, understanding this integration is essential. If you are curious about how robots function, you are in the right place. From an electrical engineering perspective, robotics programming and hardware components are tightly connected through several key processes and interfaces. Robotics programming involves writing software that controls a robot's behavior. This software interacts directly with hardware components such as sensors, actuators, and microcontrollers. The integration primarily occurs through application programming interfaces and system interfaces. Software engineers design these interfaces to allow the robot's hardware, like sensors and actuators, to communicate with the control software. These interfaces translate high-level commands from the program into electrical signals that hardware components can execute. They also convert sensor data into digital information the software can process. Programming must handle input from various sensors, such as proximity, temperature, and motion. It also sends commands to actuators like motors and servos. This requires precise timing and coordination to ensure the robot responds correctly to its environment. Electrical engineers focus on wiring and signal conditioning, selecting components that match the software's requirements. Robotics hardware often includes embedded microcontrollers or processors running real-time operating systems. Programming these systems involves low-level coding in languages like C or Python. This coding directly manipulates hardware registers, manages interrupts, and controls power usage. This close coupling allows the software to manage hardware resources efficiently and safely. The integration is not just about connecting hardware and software but also designing the overall system architecture. This includes deciding how components communicate, either wired or wireless, how data flows, and how to handle errors or failures. Electrical engineering principles guide the design of circuits and power systems that support the software's operational needs. To streamline integration, engineers use Mechatronics labs and platforms that combine hardware and programming in realistic settings. These environments help validate how software controls physical components and allow iterative improvements before deployment. Embedded systems in robotics must be secure and reliable. Programming integrates with hardware to implement safeguards against timing unpredictability, hardware faults, and security vulnerabilities. This requires careful coordination between software algorithms and hardware capabilities. In essence, robotics programming translates desired robotic functions into electrical signals and commands that hardware components execute. Electrical engineering provides the foundation for designing and connecting these hardware elements. The collaboration between software and hardware engineers is essential to build functional, responsive, and safe robotic systems.